Now that we've done an example where we complete the square for a quadratic equation where the coefficient of x squared is equal to 1, this, of course, naturally leads us to ask, well, what happens if the coefficient of x squared is not equal to 1? And that's exactly what we're going to discuss today. So as we can see over here, today the coefficient of x squared, marked in red, is 3. So 3 is clearly not equal to 1, so what can we do? Can we still use completing the square here? And the answer is yes. Yes, you can. So we're going to cover two methods for tackling something like this, and let's go ahead and jump straight into the first method. So what would we do if we were asked to solve this quadratic equation? So method 1 would look something like this. Currently, the coefficient of x squared is not equal to 1, it's equal to 3, but we can make it equal to 1 by dividing this whole thing by 3. So that's the first method. You're going to take the coefficient of x squared, which in this case happens to be 3, and you're going to divide that across all terms. So let's take this equation and let's divide both sides by 3. I'm going to make that a little smaller actually. There we go. On the right side, 0 divided by 3 is still 0. And then from here, we're going to split this fraction up into 3 parts. 3x squared divided by 3 is just x squared. 6x divided by 3 is 2x, and 5 divided by 3 can be left as it is. So another way of thinking about it is you can take your coefficient and just divide it into all other coefficients. And from here, because the coefficient of this new quadratic equation is 1, I say new, but it's actually equivalent to the original one mathematically. We've just divided everything by 3, but now this is something we can work with because the coefficient of x squared is now equal to 1. We know how to do this then. We are in familiar territory because we are going to add to both sides a very important number. Take the coefficient of the linear term, which is 2, have it, and then square it. And you're going to do this to both sides just to keep everything balanced. So 2 over 2, that's 1. 1 squared is equal to 1. Don't forget about your 5 over 3, and this is equal to 0 plus 1. So cleaning everything up a bit, the first 3 terms, x squared plus 2x plus 1, that is the same as x plus 1 squared. And 0 plus 1 is equal to 1. Now from here, we're going to isolate for x plus 1 squared by subtracting both sides by 5 over 3. Just move that to the other side and it ends up being minus 2 over 3. From here we just take square roots. Remember, we have two possible answers, a positive and a negative. And after a bit of simplifying, so that's going to be I root 6 over 3. And if this seems like a big jump, a quick review on complex numbers and imaginary numbers and rationalizing denominators would be a good idea. But that's not the main focus of this video. we're just here to get some practice completing the square, so if your knowledge on those topics are a little rusty, definitely go and review those. But we end up finding our two possible answers. And imagine trying to guess this. So that's where completing the square comes in super handy. We can find these crazy numbers without guessing. Okay, so that was the first method. I promised you a second method, which is going to work in a similar way, and it will get you the same answer. So you can definitely pick which method you prefer, experiment with both of them, and just decide which one you like better. Just pick one and get really good at it. So I've cleaned things up a bit, and let's get straight into method number 2, which is to just factor the first two terms, which in this case would be these two terms. So we can almost temporarily just ignore this 5 and just concentrate on 3x squared plus 6x. So in this case, 3x squared plus 6x can be factored as 3 times x squared plus 2x. And let's keep that 5 out just for now. And this is all equal to 0, of course. And now from here, what you're going to do is you're going to complete the square for everything inside the brackets. So we know how to do that. X squared plus 2x. What we're going to do is we're going to add, actually we've already done that before in the previous method. We add 2 over 2 squared. So that's going to be plus 1. But now notice, to keep everything balanced, we are going to have to subtract 3. We still have this plus 5, and this is all equal to 0. So if that seems a little confusing, try expanding this out. So that's 3x squared plus 6x. And then I added a plus 3 when we completed the square. So this plus 3 term wasn't originally there, so we have to get rid of it to keep everything balanced. So that's where this method can get a little bit tricky, is a lot of people might forget to subtract this term just to keep the equation true. So I think that's why most people, including myself, prefer method 1, because for this one you really have to keep track of what needs to go away because of these brackets. When you open this up, you get a plus 3 term here, so you have to remember to get rid of it. So the good news is x squared plus 2x plus 1 can be written as x plus 1 squared. And when we move all our numbers to the other side, we get minus 2. And from here, I trust you can finish as usual. So we take this term and divide by 3, and it's familiar territory. Take square roots, positive and a negative, and rationalize denominators. You're going to get an imaginary portion and then isolate for your variable. So in the end, you should actually get the same answer of minus 1 plus minus I root 6 over 3. So I'll leave you to finish that on your own. This was just to show you 2 methods that you can possibly choose from when your coefficient of x squared is equal to something other than 1. So now that we know how to factor quadratic equations with the coefficient of x squared equal to 1 and the coefficient of x squared not equal to 1, so equal to something other than 1, let's get some more practice with some harder examples for completing the square.